Have a break, have a coffee. Welcome to a new episode of Unpacked, the Siemens Packaging Podcast. A robot that brings me coffee at my desk. Great idea. Although, then I wouldn't move at all, so maybe not. But one thing that's definitely a very good idea is integrating robots into packaging processes. However, this means you have to think a bit outside the box. Philipp Rösner knows how to do that. He's team leader for software development at Optima Consumer GmbH. They create robotic solutions for packaging machines that are quite special. One of their firsts, developing an ergonomic workplace for robots. This episode also marks a first for Unpacked. It was recorded live in German and then translated using AI for your convenience. Enjoy! So how are the robots doing at Optima Consumer GmbH? Let's ask.
Hallo Kerstin, ja, vielen Dank für die Einladung.
Hello, Kirsten. Thank you very much for the invitation. Our robots are doing well, and so are we humans, of course. Thanks for asking.
Well, Philipp caught me a bit off guard there, but obviously he's doing fine. So what is he up to?
Also wir als Optima Consumer, wir bauen Verpackungsmaschinen für...
At Optima Consumer GmbH, we build packaging machines for everyday consumer goods, such as coffee pods, water filters, and cosmetics. What's a bit special about our systems is that we integrate robot kinematics into our machines. That means we use controller-independent robot mechanics, where the robot is controlled by our machine PLC.
Das heißt also, dass der Roboter von unserer Maschinen SPS kontrolliert und gesteuert wird.
Which is not how it's usually done. The robot usually comes with its own controller. So why did they decide on this approach?
Zum einen sind es wirtschaftliche Rahmenbedingungen.
There are economic aspects and integration aspects. With control-independent kinematics, we have no interfaces to a robot controller. Everything runs on a single PLC. When we have processes in which we need to synchronize, say, a robot with a conveyor or a transport belt, it's easy for us to combine these different units in synchronous motion.
Synchron zu kombinieren und einen Gleichlauf zu generieren.
Which leads us to the next question. What are the benefits? This is what Philipp said.
Es ist so, dass wir bei uns in den Anlagen Prozesse haben.
We have processes in our machines that run continuously, and we don't want to interrupt them. In this case, we need synchronization so that we can, for example, lift coffee capsules from a conveyor belt in synchronous motion and then place them somewhere else. And of course, if we have synchronization, we don't have stop-and-go operations, which cost time and reduces machine performance.
What was interesting for me was how they engineered this synchronicity.
In den letzten Jahren hat sich da einiges getan. Das heißt,
in the last few years, we've seen a lot of improvement. Controller suppliers, for example Siemens, now provide ready-made modules that we can just configure. This means that Siemens has these technology objects that we can use to configure arm lengths for a robot, for example, and create the basic structure. We can use these functions to set up motion paths as well. And synchronized motion is also a function provided by the suppliers.
Die da schon von dem Steuerungshersteller bereitgestellt werden.
Out-of-the-box, ready-to-use solutions sound fine in theory, but what about special requirements?
Das kommt immer ein bisschen drauf an. Also viele
It depends. We can use a lot of things out of the box. As I mentioned, a lot has happened in recent years, and integration is getting better and easier. But sometimes there are also scenarios, very specific start and stop cases, where we have special conditions, for example, where we have to place coffee pods somewhere else because there was an error in the shift register with a component or a capsule. Then, of course, it gets complicated, and we have to program something for the application.
Das kommt auch vor.
So they still have to make adjustments to the kinematics, but how do they find the right solution? I was interested in the tools and methods they use for that.
Also zum Beispiel hatten wir ein Projekt, da wurde die Roboterposition optimiert.
Well, for example, we had a project where we optimized the robot position. That means we knew the application and knew that we wanted to transport parts from one position to another. We knew which robot we would use and how many degrees of freedom we had. Then we started moving the robot around in virtual space and shifting the robot base until we achieved maximum output. We then implemented it that way, constructed the machine frame, and positioned all the other parts. In other words, we built the machine around the robot application.
Sozusagen die Maschine die Roboterapplikation drumherum gebaut.
Now, that's an interesting idea. What Optima Consumer GmbH did there was build an ergonomic workplace for robots.
Exactly, to allow the robot to operate at its full potential, which then, of course, results in high output. And that's what we want. The machines need to work well and at optimal speed.
Gut und zügig arbeiten.
Changing the mechanical and machine design to better fit the robot is quite a bit of a step. So how did the teams react?
Ja, also bei dem ersten Projekt, wo wir das umgesetzt haben, da war natürlich schon erstmal.
In the first implementation, our colleagues were naturally a little skeptical when we explained that we had to reposition the robot in order to achieve higher output. It took a bit of convincing, but in the end, the teams agreed and implemented the ideas and specifications that we'd worked out in advance in the simulation.
Vorgaben, die wir da in der Simulation vorab rausgearbeitet haben.
But did the results match the simulation? That was my next question.
Ja, zum Glück ja. Also,
yes, fortunately, it did. We built everything the way we'd simulated it beforehand, and we were able to achieve the target output after a relatively short time, after about a week of commissioning. We then ran another iteration and were able to improve it further. This is just because we had to assume values for certain parameters up front, but then we realized that we'd been very conservative. We improved and optimized everything a bit, which showed that this process works and that it's effective.
Dass der funktioniert und dass das zielführend ist.
Which clearly demonstrates that it's worthwhile to consider how you can make life easier for the robot. And that was something I'd never heard of before. That's why I enjoy doing this podcast so much. I always learn something new. Unfortunately, our time was up and I had to let Philip get back to work. Today's episode was a bit of a tech deep dive, but that's what made it all the more interesting. Controller-independent mechanics for perfect synchronization between robot and machine, and an ergonomic workplace for robots. All this is necessary to ensure that the kinematics run smoothly and can reach their full potential. That's it for today. You'll find the transcript next to the recording. Thanks for listening, and please like, subscribe, and share.